number 17, we're doing the pSAT. This is practice problem number 1 found on Khan Academy, or practice test number 1. Number 17, so we have a summer camp counselor wants to find a length of X and feet across a lake represented by the sketch above. The length represented by AB, EB, BD, and CD on the sketch were determined to be 1,800 feet, 1,400 feet, 700 feet, and 800 feet respectively. I'm going to pause right there because that's kind of the key information here. So AB is 1,800 feet. Label it. AB, 1,800 feet. This length right here, 1,800 feet. Put it in the lost and found when you're done with it. This length EB right here is 1,400 feet. 1,400. 1400. And then I have 700 feet for BD, 700 feet for BD, and 800 feet for BC. Or sorry, CD. Oh, yeah, there it is. So CD is 800 feet. And I need to figure out the angle of X. And this is a geometry problem, which you guys have not seen yet because you are just taking geometry. But this is similar triangles. So when I set up my similar triangles, I need to set up a big triangle and a small triangle. Write them down. The key thing about similar triangles is when I draw these triangles, this angle and this angle need to be the same. This angle and this angle need to be the same, and finally this angle on the top and this angle on the top need to be the same. If they're not, then you're in trouble. And that's the tricky part about this problem. I'm going to say that these two angles are the same. You guys know why these are the same. Can anyone tell me why? Why raise hand? Sergio? Vertical angle. So I know that the top here is B for both of them. B and B. All right. Now the next question I have is if I say that the bottom left corner, I'm just going to randomly say E. At the bottom left corner is E here. E matches up with which angle? For the small triangle. E, this angle right here, matches up with which angle in the small triangle? We have to read the rest of the problem. Angle AEB and CDB have the same measure. This tells us our answer. So what is it? Which two angles are the same? Give me 2 letters. 2 letters that are the same. Monse. E and D. So E should match up with D, and then by process of elimination we have A and C. A and C. We have labeled our triangles. We have made sure that all the angles match up accordingly. Now what we need to do is label these triangles. So, what is the length here of AB? What is this length AB? Quiet raised hand. This right-hand side of the big triangle. What is the length of AB? Look at your diagram. Andres. 1,800. Label it. What about EB, the left-hand side? What is that? What is EB, left-hand side? This line segment, EB, side of the triangle. Jose? 1,400. It is indeed 1,400. Again, I'm just matching. EB, the length in between here is 1,400. Let's do BD right here. BD. What is this length on the left-hand side of the small triangle? Easy XP here. DB, BD, whatever you want to call this. What is it? Sergio? 700. And finally, what is our last measure? This last measure of 800, where does it go? Does it go on the bottom or the right? Andres?
CD.
It is CD on the bottom, 800. The last, I guess we forgot to label X. X is EA. EA right here is the one that we're trying to find, so that's going to be labeled X. And then we have to match them up. We say that X matches with 800, so we make a proportion. We can say X and 800 have the same ratio, and then we have to match up 2 other sides that are the same. So X and 800 were both the bottom. I can either match up the rights or the lefts. Which makes sense? Jose? Why? They are nice numbers. They did make it work out, but that's not exactly the reason what am I missing here? I'm missing just a length, right? I can't even set up a proportion if I don't have anything. So that's the main reason I can't use BC. Jose, tell me what my ratio is going to be. If I did x over 800, then it's going to be 1400 over, there it is. We've set up our proportion using similar triangles, which we will eventually do in geometry. And then we just need to solve. So I'm going to divide the top and bottom here by 100. So if I divide 1400 by 100, I get those two cross off, those two cross off. I now have 14 divided by 7. What is 14 divided by 7? Is there a quiet raised hand that can simplify that fraction even further? It's the same 3 people. Come on, I need more people. What's 14 divided by 7? Going back to, thank you, Josie. 2. So I'm now changing this problem into x over 800 is equal to 2, or 2 over 1. All right, we've simplified. Now I need to solve. When I have a fraction equal to another fraction, this I think was a review from 8th grade, what do I do? Question, Andres.
So I kind of got lost when you did x over 800, but why'd you put equals 1400 over 7?
I say that this measure, x divided by 800, is the same as 1400 divided by 700. And you haven't learned this yet, but the proportion between the big and the small is always preserved. So I can say big divided by small is the same proportion as big divided by small.
Oh, okay.
That's why I'm setting up the proportion. All right. When I have a fraction set to another fraction, I do this. What is this thing called? Jose? Cross multiply. Can you do that for us? What's 1 times x? All right. And then what is 2 times 800? There it is, 1600. There's your final answer, 1600. All right, we're on to number 18. We have a system of equations of above. We need to find the value of x. So, if we want to find x, we should eliminate the other variable. We should eliminate y. Do you guys want to use substitution or elimination? Does not really matter. I can show you both ways. The fastest way to do these is elimination. So, if I were teaching you about speed, I would say elimination. Jose? By one of those. You could do that. So if I did like this thing times -1, which variable would I be eliminating? X. But we're trying to find x, so we should eliminate the other variable. You are 100% correct. If you want to find the answer, you can eliminate whichever one you feel like it. But for the SAT, it matters about speed, so we need to eliminate the y. So how could we eliminate the y? What could I multiply this top equation by to eliminate these y variables? Sergio? There it is, times by -2. I'm going to rewrite that equation. So -2x minus 2y is equal to negative times a negative is a positive 18. All right, I'm going to go ahead and scribble out this first equation because it's now used up. We have these two equations. I'm going to add them. Add them together because by adding them together, 2y and -2y will cancel out, and I have eliminated the y variable. So here we go. X plus -2x. Quiet raised hand. X plus -2x is what? Same people over and over again. Can I get anyone new? X plus -2x. No one new? Eder? -1x. Perfect. Thank you, Eder. -2y plus 2y, that's gone, so 0 here, so plus 0, we can just eliminate it. And that's equal to -25 plus 18. What is -25 plus 18? Fernando. Negative.
Oh, wait, what was it?
-25 plus 18.
Would it be negative?
It would be negative something.
Did it say 25?
You said -5.
Oh, it's because I thought that was a 3. I don't know. -7.
It is indeed -7. Thank you. And finally, I need to solve for x Right now I have negative 1x. I just want regular 1x. What do I do to both sides? Andres?
So you divide both sides by -1.
By -1, and I get x is equal to
7.
There it is. I guess we should be checking our work here too. For number 17, we got 1600. For number 17, 1600. And for number 18, we got 7. Cool. We're doing good so far. Number 19. In a right triangle, one angle measures x degrees, where sine of x degrees is 4/5. This, we have not even touched trigonometry. But again, it's another thing that you're going to learn in geometry. I'll show you how to do this one, but I can't teach it in depth because it's like a whole lesson just for this one type of problem. So if I have sine, how many of you have heard of Sohcahtoa before?
Huh?
Yeah.
I've heard of it, but I forgot about it.
Okay, well, here's your brief synopsis. Write out Sohcahtoa like this. Sohcahtoa is a way to remember the 3 trig functions that you use on a regular basis. Well, at least on a regular basis when it comes to mathematics. Sohcahtoa. It's just a good way of remembering what sine, S-I-N-E, cosine, and tangent. These are the 3 trig functions, and they're opposite over hypotenuse, adjacent over hypotenuse, and opposite over adjacent. That probably sounds like Chinese to you since you haven't even learned what those are yet. How can I make this as brief as possible and still make this valuable? I'm going to go ahead and make a right triangle over here. I'm going to say that my angle of reference is over here. I'm going to call this x degrees, or I could call it theta degrees, but for this problem we'll call it x degrees. If this is x degrees, do you guys know which one is the hypotenuse between this leg, and this leg? Which one is the hypotenuse? You guys have learned this before. Andres?
The right one?
This one right here?
Yes.
This one is actually a leg. This one is actually the hypotenuse.
Oh wait, never mind. Okay, yeah.
The hypotenuse is always the longest one or the most diagonal one when it comes to a right triangle. Adjacent, if you are really strong in your vocab, you know that adjacent means right next to. My neighbor that was adjacent to me had a baby that was crying all night. My adjacent neighbor, the one that was next to me. So between this leg and this leg, which makes sense to be adjacent next to our angle x? The right or the bottom? Shout it out.
Bottom.
It is indeed the bottom. The bottom is going to be the adjacent. And then opposite, the farthest across, all the way across the triangle, that is the opposite. So this is the opposite. So this is saying that sine of x is 45. Well, sine is opposite over hypotenuse. So if I make a new triangle with angle x degrees, the opposite is 4 and the hypotenuse is 5. That is what O over H means. The opposite is 4 and the hypotenuse is 5. Who can label this triangle with opposite is 4 and the hypotenuse is 5? Just using these words up here. If the opposite is 4 and the hypotenuse is 5, where do the numbers go? Fernando.
5 goes on the top.
5 goes on the top, the hypotenuse right here, and then the 4 goes
on the yeah, there.
Right here? Okay. Yeah, on the right hand side. There it is. It's asking what is cosine of 90 minus x? And again, if you are really tricky, we know that there are 180 degrees in a triangle. Nod our heads. Something that we definitely know. 180 degrees in a triangle. If this angle is 90 degrees, what do these two angles add up to? The bottom left and top right. These two angles must add up to what if 90 has already been used up?
180.
Jose?
So those two angles have to equal 90.
Yes, these two angles should be equal to 90. So if I do 90 minus this angle here, I'm now talking about this angle up here. 90 minus x is talking about this angle right here. And then I wanted to do cosine with respect to that angle. And you have to kind of look at this and tilt your head. You could say, okay, if this is my angle of reference now, this is the opposite, this is the adjacent, and this is the hypotenuse. Cosine says adjacent over hypotenuse, so adjacent over hypotenuse. So it's the same ratio. Cosine says my angle's now here. My angle's moved from here to here. My adjacent is the one that's next to the angle. Hypotenuse is still the diagonal one. Cosine is saying adjacent over hypotenuse, adjacent, the one next to me, 4 divided by 5. So the answer here is 4/5 again. And this went over most of our heads, but I mean, it's the SAT. You haven't taken geometry, so that's what I would expect. So the answer here is 4/5. Even for students that take geometry, this is still a hard question. So the fact that you haven't learned this and it's a hard question makes it kind of pointless for me to teach, but there it is. All right, number 20. If a is equal to 5 square root of 2 and 2a is equal to the square root of 2x, what is the value of x? Okay, so we can do a simple substitution in this case. If a is 5 over 2, plug in that 5 over 2 right there. So here we go. 2 times 5 square root of 2 is equal to the square root of 2x. Okay, so now I can rewrite this as 2 times 5 is 10. 10 square root of 2 is equal to the square root of 2x. Nothing too fancy happening. I just multiplied 2 times 5 on the outside. But I have these pesky square roots. Is there some way I could undo square roots? What's the opposite of square rooting something? Does anyone know the opposite of square rooting something? Andres?
Rooting the square.
It's squaring it. If I square both sides, it gets rid of the square root. This square root is gone, and I'm left with just 2x on the right-hand side. If I square the left-hand side, you have to be careful. What this is really saying is 10 squared times the square root of 2 squared. Are you okay, Gunnar? All right. Square root of 2 squared, these squares will also cancel each other out, so this is gone, and this is just 2. What is 10 squared? Jose? 100, and then I have to do 100 times 2, and I get, there it is. So 200 is now equal to 2x. What is x equal to? Fern? X is equal to 100. And again, we can check our work. Did we get this one right? Whoa. Yeah, number 20 was 100, and number 19 was 4/5. We're doing good. All right, those were some really, really hard questions. So now we're going to go even harder. We're on to the next packet. You guys have the next packet? So notice the time limit on this one. 55 minutes and 38 questions, which means you have more than a minute per question. If I did 55 divided by 38, you get about a minute and a half. A little under a minute and a half now per question, because they expect you to have to spend some time punching it into the calculator. So again, section number 3 was without a calculator. Section number 4 is with a calculator. Again, they give us the same formulas that we had in section number 3.
Are there different sections on the SAT, Mr. Sino, too?
Yes, they're the same section. So section number 4 is going to be math with a calculator. Section number 4 is going to be math without a calculator. Section number 1 and 2 are English, writing based, stuff like that. Definitely without a calculator.
Without math?
Without Spartan notes?
All right. I am going to open this up for maybe 5 minutes so you can try these problems. If you want to give up and say that's too hard, you can move on to the next one. Look at 1, 2, 3, and 4. I'll give you guys 5 minutes. Good luck. All right, so we're now on section 4, still in practice test number 1. So we have John running at different speeds, and this is his heart rate. So his heart rate versus his time. And we need to find an interval that is strictly increasing, then strictly decreasing. What that means is that I'm never going as a flat line. That is neither increasing nor decreasing. It says you are only increasing and then only decreasing. No flat lines. You're not allowed to have that. That's what strictly increasing and strictly decreasing means. Between 0 and 30, that's this interval right here, is strictly increasing, then flat line. Nope, not A. B, between 40 and 60. Between 40 and 60, it's strictly increasing, then decreasing. There's our answer.
But you could also do 50 to 65.
50 to 65. Let's check it out. 50 to 65. 65 is right here. That is decreasing, then increasing. It said increasing, then decreasing. D says between 70 and 90. 70 and 90, we have a flat line. Not D either. All right, number 2. If y is equal to kx and k is a constant, y is equal to 24 and x equals to 6, what is the value of y when x is equal to 5? So, plug in these two numbers first and see what happens. So if y is equal to 24, 24 is equal to k, and what was x? X was 6, k times 6. Therefore, k is equal to what?
4.
4. So my new equation is y is equal to 4x. And then it's asking, what is the value of y when x is 5? So I'm going to re-plug in 5, and I get what?
20.
There's the answer. 5 times 4 is 20. On to number 3. We have parallel and perpendicular, or no perpendicular lines, only parallel lines. You guys know the trick. Small angles and small angles are the same. You don't have to do a proof on this one. SAT is all about the trick. The trick is, if this is small and this is big, do 180 minus 35. The correct answer is 145. Done. Next question. Number 4. If 16 plus 4x is, whenever you see the word is, it's an equal sign, is 10 more than 14, 10 more than 14, what is the value of 8x? Oh, you got it right, Andres, my bad.
Wow, Mr. Chanel. And wait, that's a teacher.
It is. 24 is therefore equal to 16 plus 4x. I'm going to subtract 16x on both sides, and I get, or not 16x, just subtract 16 on both sides, and I get 4x is equal to 8. Am I solving for x, or am I solving for 8x?
8.
Okay, so I'm not solving for x anymore. I'm solving for 8x. Let's multiply both sides by 2. 8x is now equal to 16. Done.
I told you, like, oh, I told you, I think I did 16 in the certified Einstein.
Your homework tonight, which you can begin right now. We are going to start at number 5. Your homework over the weekend, I should say, is 5 through 12. Circle number 12. Do all the problems through number 12. 5 through 12. Good luck.